Continuing with rational functions, we're going to look at how to find the horizontal asymptotes. We've already talked about how to find the vertical asymptotes. Now let's talk about finding the horizontal asymptotes. When we're looking at the horizontal asymptotes, we have to look at the degree of the numerator and the denominator. And we're going to compare these degrees. And where we compare the degrees, we have three different options. Option number one, if degree of the numerator is larger, there is no horizontal asymptote. So for example, if we have f of x is equal to a 3x squared divided by an x plus 1. The degree of my numerator is 2, whereas the degree of my denominator is only 1. So the degree of the numerator is larger than the degree of my denominator, so I have no horizontal asymptote. My second option is if the degree of my numerator is smaller. If it is smaller, my horizontal asymptote will be at y is equal to 0. It'll be at that x-axis. For example, if I have g of x is equal to, we'll say, 4x divided by an x to the third plus 2x minus 5. Notice my degree of the denominator is 3, whereas the degree of my numerator is only 1. So the degree of my denominator is larger, the degree of my numerator is smaller, so my horizontal asymptote is at y is equal to 0. My third option is if the degrees are the same. If the degrees are the same, then the horizontal asymptote will be at y is equal to leading coefficient divided by leading coefficient. And I'm going to do a couple of examples of this one. So if I have h of x is equal to, we'll say, a 4x squared plus 2x minus 3 divided by a negative 5x squared plus 2, the degree of my numerator is 2, the degree of my denominator is also 2. So I look at the leading coefficients. Remember, the leading coefficients are the numbers that are attached to that largest exponent if they're in standard format. So in this case, my horizontal asymptote would be at y is equal to 4 over a negative 5 or a negative 4/5. Another example of this would be if I have m of x is equal to x plus 4 times a 3x minus 2 times a 5x plus 1 over x to the third plus 2x. Now the numerator is in factored form whereas my denominator is in standard form. But if you notice my numerator, the degree is still 3, and the degree of my denominator is 3. Leading coefficient of my numerator is I have to take the numbers in front of each of my x's and I need to multiply those. So I need to take 5 times 3 times a 1. So 1 times 3 is 3 times a 5. So my horizontal asymptote, would be at y is equal to a positive 15. And then my leading coefficient of my denominator is 1. So I'd be at y is equal to 15. So you have to pay attention, if it's in factored format, the coefficients of all of your x's together. And then let's look at one more. Let's say I have k of x is equal to 3 plus 7x squared minus 8x to the 5th divided by 4x to the 4th plus 2x to the 5th minus 9x. Now if we look at our degree of our numerator, remember we're looking for that largest exponent, so that's a degree of 5. Degree of my denominator is also 5 because I'm looking for that largest exponent. So my degrees are the same, and so whenever I go to do my horizontal asymptote, that will be at y is equal to my leading coefficient. So my leading coefficient is the number attached to the x with that largest exponent. So that's going to be a negative 8 divided by a positive 2. I don't just take the number in front. I would highly recommend you rewrite this in descending order. In other words, from the highest exponent to the lowest, so that you can get that leading coefficient. So in this case, my horizontal asymptote would actually be at y is equal to negative 4. So be careful when you're having to do leading coefficient over leading coefficient. Make sure you actually get the leading coefficient and not just the coefficient that's sitting out front.